Hello and welcome to the disassembly of a gearbox with calculation of the gear ratio. I've got a small gearbox here with electric motor, the electric engine, the drivetrain to the wheel, and the electric engine in this case has a voltage of around 3 to 6, in some cases 9 volts, and the current is maximum current is around 200 milliamps. Therefore the engine is not very powerful, but it is sufficient for small robot cars and the application with Arduino microprocessor. Right now I do the disassembly of the gearbox. I take the wheel from the gearbox and we now see the output shaft, the gearbox output shaft, which has an output speed of around, at 3 volts, around 100 revolutions per minute, 100 RPM. And I take off the clip of the electric motor and we open the gearbox housing, and the engine already wants to escape. We see the engine with the gear wheel and as far as I see, the gear wheel has 8 gear wheel teeth. This is in order to calculate later the gear ratio of the first gearbox transmission step. So in this case we have 8 teeth. I'll leave it here and we dismantle the gearbox housing. And once again we recognize that the gearbox is equipped with 4 transmission steps and except the engine gear wheel, it are 4 gear wheels of the gearbox. One with the output shaft and an intermediate gear wheel, one more intermediate gear wheel, and this is the first gear wheel after the engine. And the engine, the electric motor, drives this first gear wheel, and I already have counted the number of teeth of this gear wheel here. It were 24 teeth on this gear wheel. This means our gear transmission ratio for this first gear step is, this is gear wheel number 1, and the outer gear wheel here is gear wheel number 2, and I call this therefore the gear ratio I1 2 from gear wheel number 1 to gear wheel number 2. This gear ratio is the ratio of gear wheel teeth of gear wheel number 2, which was 24, divided through 8 tooth of gear wheel number 1, and there the transmission ratio of the first step is 3.0. So right now we assemble it again. Put it in here. The next transmission step is to this gear wheel here, and therefore we need here the gear ratio from the outer gear wheel to this small gear wheel here, which has also 8 teeth, and the outer gear wheel on the next gear is equipped with 36 teeth according to my counting. Therefore the next gear ratio of the second step is from 3 to 4, from gear wheel number 3 to 4. This is the ratio of the gear wheel teeth number 4, 36 teeth, divided through the number of gear wheel teeth of gear wheel number 3, which was also 8, and therefore this transmission ratio is 4.5. For the next gear ratio, the next step, we need gear wheel number 3, and we see the gear ratio here is the gear ratio of the inner gear wheel here to the outer gear wheel here. And for this purpose I have also counted the number of gear wheel teeth. It is the transmission ratio I56, and for this I need the number of teeth of this gear wheel, which was 28, divided through the number of teeth of the inner gear wheel here, which was 16, and we get a gear transmission ratio of 1.75 for the third gear transmission step. The last transmission step is the step to the output shaft right here, and we see the gear ratio in this case is the ratio from gear wheel teeth of the big gear wheel here to the number of gear wheel teeth of the inner gear wheel here. This one. And I have also calculated, respectively counted, the number of teeth and the bigger gear wheel was equipped with 30 teeth, and these were 30 teeth, and right here it were 14 teeth, and so we receive a gear transmission ratio of the last transmission step of 2.143. So right now we can calculate the total gear ratio. This means the gear ratio from the electric motor this means the gearbox input shaft here, to the gearbox output shaft. And for this purpose we have to calculate the total gear ratio. Gear This total gear transmission ratio is from gear wheel number 1 to gear wheel number 8, and therefore I call it I. Total is I18. And in order to receive this total gear ratio, we have to multiply all the single gear ratios and this means 3 multiplied with 4.5 and with 1.75 and 2 multiplied with 2.143, and we receive a total gear ratio for this gearbox of around 50.6. A gear ratio of 50.6 means that if the engine speed, for example, this engine speed of the electric engine, if this engine speed is assumed, well, if we use around 6 volts for the electric motor, the speed of the gearbox input shaft, this means the output shaft of the electric motor, this speed will be around 14,000, and therefore the output speed of the output shaft here will be, let's say, 15,000 divided through 50, and we will receive an output speed of around 300 RPM. So I assemble the gearbox once again. We put the engine in. So, and therefore, if the engine speed is 15,000 RPM, we will receive on the output shaft around 300 RPM. This is corresponding to a voltage of around 9 volts on the electric engine. And so I have completed my calculation, and thank you very much for watching.